vectors. So vectors are projectile motion. Vectors are dealt with a lot throughout the entire year, so please do not neglect them. They are something you have to remember, because they do end up being worth quite a few marks on the external. So a vector is a quantity defined by a direction and a magnitude. So for instance, say a boat was going east at 10 kilometers an hour. That has not only direction, but it also has magnitude, the direction being east and the magnitude being 10 kilometers an hour. If you were to just say it's going east, then that's not a vector, that's a scalar quantity. So you've got to make sure it has both of those. It's often useful to split up vectors into horizontal and vertical components, and we will have a look at this a bit more when we get into projectile motion. So for instance, to calculate vertical height or horizontal range of a projectile. So as we can see here in the little picture, projectile motion consists of separate horizontal and vertical velocity vectors. These vectors are independent and occurs simultaneously. Simultaneously means at the same time, if you're not so sure. Gravity would only accelerate the vertical component of the motion, whereas horizontal velocity would be constant, assuming that there is no resistance. That is really important to remember, and I will underline that. Assuming no resistance. But assuming is the key word I'm talking about here. Reason being is because when you go through a lot of physics questions, it doesn't necessarily just have to be vectors of projectile motion. You have to remember your assumptions. And it's good to listen, that way you know what variables you do need or don't need. Because what do they say? Oh, air resistance does count or doesn't count. You've got to remember what's important to you answering this question. So they're saying assuming no resistance. This could mean air resistance. So that basically means that either Vx, or in this case maybe Ux, is constant between these parts, because they each have the even number of spaces. They're all the same size, so that means the velocity in the x direction does not change. However, due to gravity, Uy, or Vy, depending on how you look at it, I'm just going to call it Uy, the strength of gravity, that acceleration due to gravity, brings that cannonball closer and closer to the ground faster and faster. So it starts off really weak and then it gets stronger. So you can see that these gaps tend to widen. But yeah, always remember that Ux, or the horizontal component of velocity relatively stays the same, assuming no resistance, whereas vertical velocity changes due to gravity. Alright, now let's get into the formulas that we need. So we've got a few here that we're going to deal with, and I've already kind of talked about a little bit about some of these variables, but we're going to go over what each of them are, because sometimes people see S and they're like, wait, what is that again? Wait, why is it SY? Wait, why is it squared? So I'll go over what each of these formulas are for really quickly. But before I even do that, I just want to say, in physics, at least for the QCE system, gravity is 9.8. It's not 9.81, it's not 9.79 as I've seen in some textbooks, it's 9.8. Just leave it as 9.8. But yeah, so just remember that it's always 9.8, and that's what it says outright in your formula sheet as well, so just stick to that. Okay, to the formulas, so let's look at this first one. So we've got Vy, and Vy is velocity in the y direction, so the vertical direction. And I'm just going to do a little drawing down here. So say something gets thrown up in the air and comes down to land. As you saw on the last slide, I used UX and UI, and there's a reason for that. So I'll show you now. Up until about this point, initial and vertical velocity is signaled by U. So this is initial velocity in the horizontal direction. This is initial velocity in the vertical direction. Oh wait, did I say horizontal for the bottom? Horizontal is UX, UI is vertical. There you go. Sorry if that was confusing, but it's the U stands for like initial velocity. Okay, and then if I get another color, you'll notice throughout this lecture that I love using the different colored markers. Yeah, because then the ball in this scenario reaches a point where velocity in the y direction reaches 0, and then it just starts descending. All in the while when UX or VX stays the same. So now it starts turning the other way after that halfway point. So this is Vy. So that vertical velocity changes its direction. And then we've got that horizontal velocity. Okay. So that's how it works. That's what each of these variables are. So you got UX being initial horizontal, you got UI being initial vertical velocity, you got Vy being final velocity that's vertical, and then you got Vx, which is final velocity in the horizontal direction. You get the gist. Anyway, it doesn't have to be a very specific name, but that's what that means. So back to this first formula. To calculate the final velocity in the vertical direction, it is equal to gravity times time plus the initial vertical velocity. Sy is vertical displacement, and then you know the rest of those variables. Yeah, and then one key thing here to remember that people always tend to forget when doing questions is that Vx is equal to Ux, okay, because that horizontal velocity never changes. And yeah, I'm pretty sure that's it for those. If you have any questions, pop them into the chat if you're not sure about any of these. But just so you know as well, say you've got a variable that you don't know in one, but you can utilize another formula to help you out. Like say you're trying to find Vy, but you don't know Sy, so you got two unknowns. You could always use this one. That was a bad scribble. You know what I mean? To plug it into there, provided you know what time is and what UI is, but you have to know what UI is anyway for this part. So you can really manipulate these formulas to work in favor of what you do or don't have.